Hey, this is the AP Calculus Chapter 4 review video. This one's number 1. It's going to be one of 3. I'm going to work 12 problems from Chapter 4 to try to get you back up to speed on the things that you need to know for the upcoming test. So if you'll open your book to page 248, we're going to start with number 17. So that's x to the 3 halves plus 2x plus 1. We want to integrate that. Alright, so we take the exponent and add 1 to it. So it's like adding 2 over 2. So that would be 5 halves. But we need a coefficient out front that when we bring that 5 halves down and multiply, you get a 1 out front. So that would be 2/5. Alright, and then 2x integrating that would just be x squared. Alright, because take the derivative, it's just going to be 2x. And then plus 1, the antiderivative of 1 is x. A lot of times when people see a constant there, they accidentally take the derivative and make it 0. No, remember we're going backwards here. And then don't forget the plus c. Alright, the next one on my list is number 19. So that is the cube root of x squared dx. Now the reason I gave you such a simple problem here is sometimes students accidentally forget what they learned in the 7th grade, and then what we also went over in pre-cal, which was to change this to a fractional exponent. It's the exponent under the radical that goes in the numerator, and in the crook of the radical, that exponent is the denominator. So this is the same as x to the 2/3. I have had students accidentally do that as 3 halves. All right, and I don't want you guys to do that. So now it's pretty easy. We add 1 to 2/3. That's 3/3 plus 2/3. That would be 5/3. And then we would need a 3/5 out front. 5/3 times 3/5 is 1. Subtract 1, you'd get 2/3. Don't forget the plus c. I do have to count off if you leave off the plus c. Alright, the next one on my list is 23. Alright, so this is x squared plus x plus 1 over the square root of x. Now let's rewrite this as, I'm going to do one step that you probably wouldn't do, but this is x to the 1/2, right? And since there's just a single item in the denominator, we can divide that single item into each one. If it was more than 1, if it was root x minus 1, we couldn't do that. But since it's just a single item, we can rewrite this as x squared over root x is the same as x to the 1/2 plus x over x to the 1/2 plus 1 over x to the 1/2. Now let's rewrite it again. X squared over x to the 1/2. 2 minus 1/2 is 3 halves. So that's x to the 3 halves. 1, the exponent here is 1, minus 1/2 would be plus x to the 1/2. And then 1 over x to the 1/2 would be plus x to the minus 1/2. So all of our work is in rewriting, and now we can just take the antiderivative pretty easy. We'll add 1 to 3 halves, so that's 5 halves. But we need a 2/5 out front. Add 1 to 1/2, so that would be 3 halves. But we're going to need a 2/3 out front. And then add 1 to negative 1/2. That's going to be 1/2. But I'm going to need a 2 out front. Now let's check by taking the derivative. 5 halves times 2/5 is 1, minus 1, 3 halves. 3 halves times 2/3 is 1, minus 1, 1/2. 1/2 times 2 is 1, minus 1, negative 1/2. So many of these problems you can check and it make you confident on the test that you got the answer right. Okay, pause if you need to, and we'll move on to the next one. All right, the next one on my list is 27. All right, so that's going to be y squared times root y dy. Let's rewrite that as y squared times y to the 1/2 dy. When you're multiplying the same base, different exponents, you add those exponents. So that's the same as 2.5, which is 5/2. So that's y to the 5/2 dy. Why am I going over this? I've just seen calculus students over the years forget kind of how to do this. All right, even though, you know, we've done it some along the way. So we can rewrite, we can take the antiderivative now. That's going to be y to the add 1 to 5/2, that'd be 7/2. We need a 2/7 out front, and then plus c. All right, you can always check. Okay, the next one on my list to work is 28. Okay, 28, 1 plus 3t times t squared dt. Okay, this is one, you know, you always want to try to avoid u substitution if you can. So let's just multiply the t squared by this 1 plus 3t. If we do that, I've got t squared plus 3t cubed dt. And now we can just straight up take the antiderivative. That's going to be 1/3 t cubed for t squared plus, now the way I do one like this is I add 1 to the exponent and then I think, okay, what do I need out front? 4 times what will give me 3? Well, I believe that's going to be 3/4. 4 times 3/4 would be 3, and then we subtract 1. So plus c. So the reason that I wanted to work that for you is because you might be tempted to let u be t squared and then du is 2t, but it doesn't really get you there. It's much easier just to try, always look to use the power rule first. All right, that's 28. Let's take a look at 31. See if I can fit that in right there. All right, 31, 2 sine x plus 3 cosine x. Okay, the antiderivative of sine is minus cosine. The derivative of minus cosine would be sine. So that'd be minus 2 cosine x. And then the antiderivative of cosine is sine. So plus 3 sine x plus c. So there wasn't any rewriting here. We just had to remember how to go through that. So take the derivative. Derivative of cosine is minus sine, so negative 2 times negative sine would give you a positive 2. And then derivative of sine is cosine, so that would give you 3 cosine. All right, the next one on my list is 33. I think I can fit it in right here. Okay, so we've got 1 minus cosecant t cotangent t. Okay, the antiderivative of 1 is just going to be t. And then what trig function, when you take the derivative, gives you minus cosecant cotangent? All right, well, I believe it's cosecant. the derivative of cosecant is minus cosecant cotangent. We need to go over all those trig derivatives again. I'll do that at the end of this video. And then don't forget the plus c. All right, the next one on my list is 34. I'll try to fit it in down here. I don't know why I'm not erasing. Theta squared plus secant squared theta d theta. Well, it's just theta instead of x. So this is a straight up one. It's going to be 1/3 theta cubed. Take the derivative. 3 times a third would be 1, and then subtract 1. That's theta squared. And then what is the antiderivative of secant squared? It's just tangent. Boom. All right, the next one on my list is 35. And I'm going to take a chance and see if I can. I'm working around a music stand here. That's why my writing is suddenly a little bit wonky. Secant squared theta plus, nope, that's not what it says. It says minus sine theta d theta. All right, we've already done. What's the antiderivative of secant squared? It is tangent. And then minus sine. So the I believe we're looking at plus, man, I'm sorry, it's so messy, cosine theta plus c. So the derivative of tangent is secant squared. The derivative of cosine is minus sine, so we'd have to have a plus and then plus c, so boom. I think I'm going to be forced to erase now. All right, the next one on my list, let's see, that was 35. So we are going to move over to page 250. So flip over to 250. And I'm going to work some of these velocity problems for you. And the first one I'm going to work is 57. So I'm not going to bring the book into view of the camera here. So hopefully you have your book open and you just read along. So it says we're using A of t is equal to minus 32. All right, so 57 says a ball is thrown vertically upward from the ground with an initial velocity of 60 feet per second. How high will the ball go? Okay, so our initial velocity v naught is equal to 60. So v of t, we would integrate minus 32 dt, and that's going to be minus 32t plus c, but our c is initial velocity in these problems, okay? So plus 60. And then our position function, s of t, we're going to integrate the velocity function. So minus 32t plus 60 dt. So that's going to be minus 16t squared plus 60t, and then plus the initial position. Well, it's the ground. It's thrown from the ground, so the initial position, s naught, is 0. All right. So velocity has to equal 0 at maximum height. So if I can set the velocity function equal to 0, solve for time, then I can get the height by plugging that time into the position function. So we'd have 0 is equal to minus 32t plus 60. All right, so 32t is equal to 60. I'm going to have to get my calculator real quick. Obviously, it's just a smidge under 2, right? 60 divided by 32, 1.875 seconds. Man, that's a terrible 8. I did not write anything on this board over Thanksgiving week. So now we can find how high it went by finding S of 1.875. So that's minus 16 times 1.875 squared plus 60 times 1.875. All right, well, let's put it in the old calculator here. 1.875 squared times negative 16 plus 60 times 1.875. 56.25 feet. All right, I hope that's the answer in the back of the book. I'm not going to take the time to check it, but I feel pretty confident that we did that one right. Okay, 2 more to go for this lecture, so pause if you need to. The next one I'm going to do is number 62. So 62, we are using A of t is equal to minus 9.8. All right, so it says the Grand Canyon is 1,600 meters deep. At its deepest point, a rock is dropped from the rim above this point. Express the height of the rock as a function of time t in seconds, and how long will it take the rock to hit the canyon floor? Well, the height of the rock is S of t. First, let's get V of t. We're going to integrate minus 9.8. So that's going to be minus 9.8 t plus the initial velocity. Well, the initial velocity, you are just dropping the rock. You are not throwing the rock down, so that is 0. And then S of t, we're going to integrate minus 9.8 t. Well, that's minus 4.9 t squared. The initial position is 1,600 feet. That's the height at the rim of the canyon, so plus 1,600. So that is the first part of the question. The second part of the question says, how long will it take to hit the canyon floor? Well, what's the position at the canyon floor? It's 0. So we would set 0 equal to minus 4.9 t squared plus 1,600. 4.9 t squared is equal to 1,600. T is equal to the square root of 1,600 over 4.9. All right. Don't have any of my solutions open, so 1,600 divided by 4.9. And then let's raise that to the 0.5 power. 18.07 seconds. That sounds familiar. I think that answer is right. Okay, last one for review number 1. You're going to get one of these videos each of the first 3 days of this week. And this will also serve as part of the review for your final exam in Chapter 4. So we have 65 is the one we're going to do. All right, 65 says, on the moon, the acceleration due to gravity is minus 1.6 meters per second squared. All right, A of t is equal to minus 1.6. Stone is dropped from a cliff on the moon, hits the surface of the moon 20 seconds later. How far did it fall? All right, so we know t is 20. How far? We'll get that in a minute, but that's going to be S of 20, right? Okay, so V of t, we would integrate minus 1.6 So that's minus 1.6t. The initial velocity, all right, are we throwing what is it? It's a stone. Are we throwing the stone down or just dropping it? We're just dropping it. So that initial velocity is 0. All right, s of t, I'm going to integrate minus 1.6t dt. So that's going to be minus 0.8 t squared. The initial position, all right, is we're going to figure that out, right? So plus s naught. All right, so s of 20, so s of at the ground, all right, s of t is equal to 0. So we have s of t is equal to minus 0.8 t squared plus the initial position. This is what we want. So we really, at the ground, it's going to be 0 is equal to minus 0.8 t squared plus s naught. All right, so 0.8 t squared is equal to our initial position if we move this to the left. So s naught is going to be 0.8 times 20 squared. All right, and we are in meters. So that's going to be 400, right? 20 squared times 0.8, 320 meters. All right, for this one, just remember you're trying to find that initial position. How far did it fall? And then the final position is 0, the surface of the moon. Okay, so on Microsoft Teams, you'll see your review homework number 1. All right, just go look at the assignment to get that. I do want to remind you real quick of the trig derivatives. You're going to want to make sure you know this by the time the Chapter 4 test rolls around. So if f of x is sine x, f prime of x is cosine x. And then, of course, you can go backwards. The antiderivative of cosine x is sine x. All right, cosine x minus sine x. All right, tangent x, secant squared x. Cotangent x minus cosecant squared x. Secant x, secant x tangent x. It's been a while since you've used these. All right, you did have to memorize them at one time. And then finally, cosecant x is minus cosecant x cotangent x. All right, that does it for review number 1. There's going to be 2 more of these videos, and I will talk to you next time.